Hey everyone, today is going to be a quick lesson and it is just continuing with some more skills that we use with expressions and equations, and we're really kind of giving you a head start into our next unit here. But we're going to be talking about distributive property and factoring. This is your second to last or third to last sheet in your packet for the week, and we're going to start by talking about the distributive property. I took the first column out of that grid of problems. I'm going to do these for you, and then I want you to do the others. Um, and again, we're talking about distributive properties. So this should be something that's familiar to you. Um, Distributive property is always using multiplication, and it's multiplying something times the um, another quantity inside parentheses. So what we're doing is we're going to take 4 of these items here in parentheses. There's 4 x's and there's 4 5's because we're taking 4 times all of this. So if I rewrote this, remember when we put things side by side, it always means multiplication, but we're taking 4 times x plus 5 here. Again, that means that we have 4 x's and we have 4 5's. So when we distribute, what we do is we write that out. And we'd write 4 x's plus, because there was addition happening here, 4 5's. I wouldn't write 4 times 5. I would just simplify that to 20. That's the distributive property. So we are just rewriting an equivalent expression. This expression means the same as this, it's just a different way of showing it. So for the next one, we have 5 of these groups of x plus 4. That means we have 5 x's and we have 5 4's. That's our distribution. So we would distribute 5 times x, 5x. We distribute 5 times 4. That's another 20. And we're going to add because that was what operation was happening between these two quantities here in parentheses. That's it. Now we're just going to look at a few more complicated versions of that. In question 7, we've got 2 different groups to look at or to distribute. And you can see that we have 6 times this x plus y. And then we're going to add on another 6 of these x plus y groups. So we're going to distribute 6 to these 2 quantities here. We'll have 6 x's, 6 times x, plus 6 times y. And then we're just going to repeat it here, 6 times x, 6 times y, like that. Addition was happening here between them. And technically, this would be right. There's a much better way, just like with fractions, when we have huge numerators and denominators, if we can simplify those numbers, we always should. And that's the same case here. If I have 6 x's and 6 x's here, everything is being added together. So I can combine 6x and 6x and get 12x, which would be a much better way to write this this other form of the expression. The same goes with the y's. I have 6 y's and 6 y's, so I should just combine that into 12 y's. And because everything's been added here, I'm just going to stick an addition sign between those. This would be the best way to write that, a simplified version of all of these terms. Okay, now lastly, we're taking 10 times everything in parentheses. The only difference here is that we have 3 terms in the parentheses. We have 1x, 2 y's, and 3 z's. I'm going to multiply 10 times each of them. So to start, I have 10x, 10 times x. Then I have 10 times 2y. So that's 20, and I'm doing all addition here. So that's 20y. Then I distribute to the last one here, 10 times 3z. 10 times 3 is 30z. And that gives me all of those three terms now that they've been multiplied by 10. Now I have a second group here. I've got 5 times x and 5 times y. And I'm still adding everything here. So 5 times x is 5x. 5 times y is 5y. And I'm done. But remember, if we have what is called like terms, if we have like terms, we need to combine them. And like terms have the same variable. So I have a like term of 10x and 5x. So I can combine that into 15x. I have 20y and 5y. So I should write that as plus 25y. And then finally, I can't forget about my last value. There's nothing to combine it with, but I don't want to forget it as I rewrite this as 30z. And this would be, again, that simplified version of the expression. Okay, that's distributive property. Now, we're going to look in the next part at factoring. The best way to think of this is factoring is doing the reverse. So in all of these, we started by multiplying the number outside parentheses times everything inside parentheses. And we did that in some version in all of these questions. When we factor, basically think of this as being the answer that we just got with the distributive property, and now we're going to work backwards. So we're going to create something that has values in the parentheses. I need two values because I have two terms here. And then I need a factor on the outside of the parentheses. So I need to look at these two terms and think, what factor do they have in common? Well, 5 and 8 don't have a common factor. So, because 5 is a prime number, 5 is the only factor of it besides 1. And when we factor, we don't want to use 1 out here. So, because for all of them we could do that, and all we're going to get is just a rewritten version of this. It's going to be 1 and then 5x plus 8x, and we don't want that. That's not helpful. But the other thing we notice is they have each an x. We could call that our factor. So we'll take out the x from each of the terms and put it outside the parentheses. Then what we're going to do is inside the parentheses put the other factor. Now remember, if we were solving this, we would take x times this first term to get 5x. Well, that means this factor inside here has to be 5. X times 5 is 5x, our first term. X times 8 will give us 8x, which is our second term. And this would be a factored version of the original expression. All right, let's look at the next one. This one's going to be a little more traditional because it's not normal that we would put the variable outside as our factor, but it does happen sometimes. So let's look here. We have two terms. Those two terms are going to have to be in the parentheses. They're going to be added. So I'm just kind of filling this in with a guide to what I'm going to be doing, and I'm going to need that factor on the outside of the parentheses. So we have 7x and 28y. What number do 7 and 28 have in common as a factor? It's 7. So I'm going to write 7 as my factor. And now what I have to do is multiply 7 times this other factor to get 7x. Well, I don't need any more numbers, I just need a variable x. So in here, in the parentheses, I would write 1x, or just x would be best. Now I have to get 28y. 7 times another factor is going to give me 28y. Well, 7 times 4 is 28, and I just need that variable there in order to get my term of 28y. Then for the last one, take my parentheses. Here I see that I have 3 terms in the expression, so inside the parentheses, I need 3 places for terms. They're all being added, so that'll be easy. And then I just need 1 factor on the outside. So a common factor of 2, 4, and 8, well, that would be 2. Let's do that. So I'll write 2. And then what am I going to multiply that by here on the inside? Well, I need to get 2x as my first term, so 2 times x would start us off. Then I need 2 times 2x, because 2 times 2x is 4x, and then 2 times 4x for the last term, because 2 times 4x is 8x. Now, really, what I could have done is I could have taken, since all of these also have an x there, let me show you what I mean. I could have taken the x out as my factor out here as well. So let me just show you another way to do that. So I still need my 3 terms inside being added together. We said 2 was going to be our factor, but I'm also going to take out an x. So now 2x is my factor outside the parentheses. To make this first term, I only need 1 of those. So I need 1 2x there. To make 4x, I need 2 of them. And to make 8x, I need 4. And this would be another way to write that, where I just took a larger term, a larger factor, out of my 3 terms. Both of these are equivalent. Just keep that in mind. And one thing I do want to mention also, for all the examples that we did, I always wrote the factor in front of the parentheses, but do remember in multiplication, the order doesn't matter. So technically, I could have written this first one with my 5 plus 8 here in parentheses. I could put my factor of x behind the parentheses, and being that they're still side by side, still being multiplied, the order doesn't really matter. The same for this one. If I wanted to put the factor of 7 here behind the parentheses, that's still okay. It's still showing the multiplication and the factoring. But please complete the examples here. On the back of your sheet, it has you using the combination of distributing or factoring. So look at those and decide which one to do and answer some of those questions. Guys, this is still kind of a new concept, but we're just leading into it before we really get into it in the next unit. So if you have questions about how it works, hop on Zoom, let's talk about it. And don't forget, you have a new iReady lesson to complete this week. If you're worried about your grade, please do an extra lesson for a bonus. Everybody have a great day.